page here of the cosine law. We are going to still use this cosine law. I'm going to introduce you to something called the compass directions. Compass directions are going to be used in navigation questions. These do come back, right? Yes, they are in this year, and yes, they will be next year, right? So this, again, the work that you put into this year will help you for next year as well, because these compass direction questions come back again. Here, if you're taking calculus, right? So if we're taking calculus, we definitely do compass direction 1. So let's start this again. We do have some questions here in the grade 11, but again, like I said, if you understand it, it'll help you next year if you take calculus. If I say north, first of all, the compass direction that you should know is north, east, south, west. I don't know how people remember it. I do north. Yeah, I do never eat shredded wheat. Yeah, is that still a thing?
I use so.
Okay, never eat shredded wheat. There you go. I don't know if there's something cooler now. Okay, but it's never, I never eat shredded wheat, so it's never, right? So there you go, or whatever one you want to remember. Okay, okay. So knowing that, right, so that's for our compass, we have north 70 degrees east. So if I write the words like this, you have to know which way it's pointing. And it's not, oh, I decided to read it this way. We all have to read it the same way. So this is saying that I was heading north, and we're reading it left to right, so it does matter. Oh, also, you can put your directions in a square bracket, but you don't have to. Again, usually in science class, we teach you to put directions in a square bracket. Math books do not write the same way as a science book, so some people will see it written in a square bracket like this, but you don't have to. Okay, usually math books, they just write it like this. Okay, so square bracket just means it's a direction, then they put it in there. It doesn't mean anything other than that. Now, this is north 70 east. You have to read it left to right. Left to right, so we're reading it left to right. I was heading north, so I was pointing north, so I was looking north, yes, looking north, and I churned 70 to the east. So this is left to right. I was looking north, and I'm churning 70 to the east. So that means you don't have to use a ruler. I'm just doing it to keep my notes neat. I churned this way 70. That's the 70. I was looking north, and I put the 70 here. You don't have to put the arrow, though. Right? So we're not actually manually churning it, but that's in your mind, you're thinking it went 70 east from the north. Okay, so I was facing north, so reading it left to right. I'm facing north, and I went 70 to the east. So I churned 70 to the east. That line there is my terminal arm. That's the arm I'm talking about. Okay. That is the same thing as... It's the same thing as, but I was looking east, and I churned 20 north. Why is this the same? How do I know that those are the same? They add to 90, right? So they add to 90. 70 plus 20 equals 90. So then when they add to 90, it means it made a nice 90-degree angle, so they connect on that same line. Does that make sense? So east 20 north is exactly the same answer as north 70 east. So if you get an answer when you're answering your questions in homework and you got north 70 east, but the book has east 20 north, you should know it's the same answer. On a test, I would accept either. Both of them are the same answer. Okay, let's try that again. If I said south, so you're heading south, and you're churning 20 towards the west. So you're doing 25 towards the west. So that would mean it would be here. So that would be 25 here. 25 between the south, churning west. Does that make sense where I put the 25? Okay, because you're going to be drawing these yourself. And then I'm going to have planes flying in these directions soon. Okay, so south and then 25 west, which is the same as, so if I wanted equivalent, it would be I was heading west, right? I'm looking west, and I'm churning how much to get to the same line? West, and I turn 65. How do I get that? 90 minus the 25. You don't have to show that. Is that okay? And then south. So that's the same as me heading west, and I churn 65 to the south. Right? So then this little missing angle here would be 65 on that side. So it's 65, 25. Does that make sense how we're getting that? So now we're going to add this to the airplane question, right? So what we were talking about before with the tower and the airplane, I can say, well, the airplane was heading, all right? And so I can add a little bit more dimension to our questions. It makes the word problems more fun. Even more fun. Even though they're already super, super fun, makes it that additional fun. Okay. Northwest. Northwest. And you go, wait, but you didn't tell me how much to turn. If I tell you northwest with no turning, then this means, or southeast, or any combination where I just put the two together. I can't say north-south, though. That doesn't make sense. If I was heading north-south, you're not heading, that makes no sense, right? So you can't be opposites. But between north and west, if I don't give you the angle it turns, it means it's north 45, exactly halfway. Halfway. Right? So if it doesn't state it, it means it's exactly halfway. So both sides would be halfway. Right? So or west 45 north. Does that make sense? So if I don't say what to turn, then it's exactly halfway. Okay. So if I said to you southeast, that would be south 45 degrees east, or east 45 degrees south. Is that okay? Okay, so we got compass directions. We're good. Compass directions, never eat shredded wheat, how to split it, how I can word it. Okay, now one more. One more compass direction. If a question says bearing, and you do have to know this because sometimes I'll say make sure you state your angle as a bearing, right? Or I'll say with the compass, right? Compass directions, but bearing is something different. You probably never saw this before. Bearing means from due north. From due north. Due north, we just stated it up here. It's here. Due north. Due north. So from due north right here. And then it goes, so from due north, this means from due north, which we have here, right? So due north, north, clockwise to the direction. So clockwise. Which way does the clock turn? Turns to the right, this way, right? So turns, when you think about the handles on the clock, it's turning this way. So clockwise means in the direction that the handles of a clock turn, this way. So that means if I said that something had a bearing of 150, that means I start at due north. So I start here, start at due north, and I'm turning it 150 clockwise directions. So I'm going to turn it. Am I going to go beyond that line? Yes, because that's 90. Am I going to go beyond this line? No, because that's 180. So stop it somewhere in here. So this is 150. So if I said that the boat is traveling with a bearing of 150, that means from due north, clockwise around 150. Okay, so these words are going to be used in a question, like in context of a question. I'll describe the way the boat or the plane or the person is moving. Right, next one, bearing of 290. So starting at due north, starting here, turning clockwise. Am I going to go past this line? Yep, that's 90. Past this one? Yes, that's 180. Am I going to go past the next line? Yeah, because that's 270, and I'll go a little bit beyond, so my line will go here. And this is 290, bearing of 290. Okay, all right, so that's the words. Now let's put it into play. See, look how fancy our word problem is going to look now. Okay, questions, or are we okay for that? Bearing, north, south. Ready? Okay, I have a smuggler. It's leaving a private airfield at 0600. Look how fancy we are. Flies on a course of north 40 degrees east at 200 kilometers an hour. Okay, we're good there? So we're flying. We're going to draw that in a second. I just want to read the whole thing first. The plane is detected by radar at the police airport, which is located 150 kilometers northwest. Oh, we know what that means. Exactly halfway between north and west. Airfield A. Okay. At 0630, right? So 0630, you gotta know how to tell time. Digital, right? The police airplane leaves the airport with the intention of intercepting the smuggler at 8:30. So this is where the question falls apart. It's like, you have a date with the smuggler? Like, why is it at 8:30 precisely? But they need the end time because then we can calculate the distance between it. Typically, I would think in reality, so if we were to make this more realistic, the police airplane is just going to go as fast as it can, and it'll get there when it gets there. And if it's at 8:20, it will meet the smuggler or intercept the smuggler at whatever time. They don't usually have the end time when they're going to meet them. So this is where the question kind of falls apart, and you're like, wait, what? So, but we need it because we need the length between. We need the distance between the smuggler and the police one. So that's where reality is actually a harder word problem, but we have to make this word problem something we can do, so we have the intercept time. Right? And in reality, you wouldn't have the actual time of interception. So they're going to meet, so and then we're going to exactly meet at 8:30, which again, that's where reality kind of falls apart. But if it was reality, there'd be a lot more variables, right? There'd be a lot more things changing. So they had to say the meet time. So this is when they're going to intercept them exactly at 8:30, which is good. Determine the direction and the speed of the police airplane to the nearest unit. So we want to know which direction should the police airplane fly, and the speed. So speed is going to be, I need the distance and how long it took. That's why I needed the time. So I need to know exactly how long it took them to reach there, and that. So it makes it a more reasonable question that we can calculate, because if we didn't have an end time, then there would be too many variables there, right? Because all sorts of other things would come into play. So it's a more contained question. So let's draw it first. I'm going to draw it over here. Try not to draw your diagram too small, and then you can't read, because what we're going to do is we're going to do these little angles here on our northeast southwest. So you have to be able to read the 65 and the 20s and stuff, right? If you make it really, really small, you're going to have these tiny angles and you're not going to be able to read it. So don't make it too small. You're going to see how big I'm going to make mine. I'm going to make it a little bit here. So a little bit off because I have to have the smuggler and a police airplane, and I know the police airplane is northwest. So typically, if you're doing this on rough paper, I would just do the diagram right in the middle of the page because I don't know which way it's heading. I'm telling you, I've got the smuggler, and the police airplane is going to be, airport is going to be over here. So I'll show you where I am on the page. I'm going to go like this, and I'm going to do somewhere down here. Northeast, southwest. Make it nice and big so you can read. Again, people make this really small, like you're trying to save space, but I need to be able to put an angle here and then fill in the angle. So if you make it really small, some people do this, and then they do their angle. I'm like, I need to fit an angle in there. So just make it big enough so you can actually fill the angles in, right? Don't make it teeny tiny. You can't read your own writing. Okay, so here we have the police airplane, the smuggler. So I'm going to call this S. This is the smuggler. Okay, so the smuggler, right? And make the northeast southwest long enough so if you cut it, you can still fill in an angle. That's the whole goal of these northeast southwest, is I gotta fill in the angle myself. Okay, so we've got police airplane north 40 east. So north 40 east. So this is north, this is east. So I'm going to go north and then 40 east, and I'm going to draw this. I have no idea how long, so I'm just going to draw it. I might have to cut it off a little bit. Okay, so I have no idea how long. I'm just going to make it long so I don't make too small of a diagram. So you can see. Okay, then I know, so the smuggler leaves a private airplane at 0600. I'll do the time stuff later. So smuggler flies north 40 east. Does everyone see how I got the 40? There you go. So that's what I mean. Make it big enough so you can read your own writing. The smaller you make this, the worse it is because you can't read your own writing. 40. Okay, so 40 at 200 kilometers an hour. I'll fill in the distances in a minute. To get distance, I need to know distance is speed times time, right? Right, so to do distance, I need speed times time. We'll do that in a second. So I know it's there. The plane is detected by the police airport. The police is 150 kilometers northwest from the airfield A. So this should have said airfield A. So this is airfield A where the smuggler is. I should have said private airfield A. A at smuggler, so this is A. Sorry, that's mine. I'm going to fix that. I'll fix that later. Yeah, so that's my mistake. I should have said a smuggler leaves a private airfield A, and then it's northwest of A, so I should have actually said A there. So I'll put A for airfield A then. That's my fault, my wording of the question. Okay, so airfield A. So it's 150 northwest. So this is north, this is west. We want exactly halfway. So I'm going to do a line here, and it's going to be exactly halfway, and I don't know where it is, but I know that this is 45, 45. So I know this is 45, 45, exactly halfway, and it's 150. So 150 kilometers there. So this is the police. Now, I don't know the distance that they're traveling here, but I do know, okay, I do know that the smuggler, so now let's highlight. The smuggler leaves the airfield at A. Airfield A at 6 o'clock. We're being intercepted at 8:30. How far has the smuggler traveled? I need the distance here. I need the distance for this. Distance is, and I'm going to just write this down on the side, so the distance is speed times time. Okay, you have to know that. They kind of assume that you have that by logic. The distance will be speed times time. If you know it's going to be 200 kilometers per hour and you've been traveling from 6 to 8:30, right? So this is 6 to 8:30 equals 2.5 hours. Does that make sense? 2.5 hours? So 2.5 hours. And we know that you're traveling at 200 kilometers an hour. So 2.5 times 200 kilometers an hour. We're going to go 2 times 2.5 times 200, which would get me 500 kilometers. That's my distance is speed times time. So this distance here is 500 kilometers long. Is that okay? They do assume that you can do kind of some of the basic kind of speed, time, distance calculations. We did that way back in grade 9. Distance is speed times time, not since, right? Distance is speed times time. Okay, so we know that this length is 500. This length is how much? It says it in the question. 150. So on my diagram, I purposely drew it too long. I'm going to shorten this. Again, I try to make my diagram useful. I don't want them both to be the same length if I know this is way shorter. I'm not going to measure it, but I want it to be shorter. So I know that this is going to be 150, right? So this one's 150 here, and this is 500. So I know that this distance here is 150, and this distance here is 500. There you go. So this police helicopter is here, and it reaches that police station right there, P. So 45, 45. What's when it reaches them, what are the two angles here?
I'm so confused. Why are they going opposite ways?
No, the police is starting here, right? The police starts at their station. The smuggler's heading here, and now the police is going to go and find them now. So they're going to go do this, okay? But this 45, 45, I need you to remember something else from, and it's been a long time, grade 9, I think is the last time we used this. You remember Z pattern and F pattern, right? So if these are both northeast, southwest, then they're parallel. So if this is 45, 45, these guys would also be 45, 45. Does that make sense? Right, so if you're leaving it at 45, by Z pattern, this would also be 45, and that's 45. They do require you, again, this is back from grade 9, I know, but sometimes you have to be able to fill in the other angle, right, and that's from Z pattern. Okay, so Z pattern means that that angle is the same as this one. So if that's 45 you left here, it's 45 there, right, so Z pattern, Z. I'll just note that down. So if in case you're wondering how I got the 45s, right? So Z pattern. Okay, so now police person's going to leave and intercept. There we go. Now we got the diagram. Isn't that much more exciting? Yes?
Why do we need that second direction?
45? I want that corner. So see how it's a triangle now? I actually want you to be able to fill in all the corners of this triangle. So see how this corner here between the orange line and the blue line, how much is that? 85? Okay, I need that orange here so I can fill it into the green. I'm going to want that corner. So I can get because it asked me at what direction is the police airplane going to head. So if I know that the police is heading here, this way, I need to know how far away it is from the east line, but I'm going to need to find the corner of the triangle. So what ends up happening is that all of these questions end up being a triangle question. I should be able to find every corner of this triangle. I'm going to find this corner, and I'm going to subtract 45 from it at the end. Right? So at the end, I'll need it. Not yet.
You're gonna find that angle and then subtract 45 from it?
Yeah. Yeah, I'm going to find this corner, and I'll subtract 45. But not yet, right? So if you're not following yet, then just hang on. We're going to do that at the end. So that comes to the direction. I just want to let you know where I'm getting that from. So we'll get back to that in a second, okay? So now we have this. When you get to this part of the question, if you're overwhelmed, what you want to do is picture it. It's just a triangle question. Every single one of these is I need to be able to draw the triangle and fill in the angles. So do I know how much this is now? Yes, that's 85. So I filled that in. Right? So I can find that one later on. I have one angle and I have two sides. We just talked about this. When I have an angle and the contained side, which formula would be best to use? Cosine law. So I'll call this one, say, x, and let's find the distance between the police to the smuggler. The smuggler is way out here. So we're going to intercept that smuggler. So I'm going to find x. So I'm going to do x squared equals 150 squared plus 500 squared minus 150, 500, and it's cos of 85. So every single one of these questions, with all of these directions and everything fancy, breaks down to a triangle question. It's the same thing when we're going to do next year. Everything, we're going to have all this fancy stuff to make a complicated, more interesting diagram. And what I want you to do is get me the triangle. So once you've got the triangle, you're solving it like normal. So x is going to be approximately how much? And you'll notice if you don't square root it, it's a ridiculously big number, right? So you have to square root it, and we're going to get 500 and I want the nearest unit, so 509, right? So it's approximately 509, and that's kilometers. If you don't square root it, you'll notice it's way too big, right? It's really, really big. You go, wait, that's crazy. That line's so long. Okay, so that's it. So break down your question to a triangle question. All of this compass directions is all just to get the corner. I just want the corner. Every time we're doing breaking this down, it's really just to get the corner.
Do we also need to find the angle?
We're not done. Yep, we're not done. So we've got that. So we've got this. We've got this. Now let's make sure we answer the question. Determine the direction and speed of the airplane to the nearest unit. So far we have the distance, right? From that distance, I can get the speed. So speed, remember from here, distance is speed times time. So when you break this down,